Below is a coin that has a square hole in its center. Picture of a coin with a hole in the middle. So I don't know why the coin has a hole, but here we go. The coin has a hole. It's a square, the hole. They set that up there. And then we have the diagram of the top surface of the coin. Okay, so we have this part here, the round part, and they've shown us that. And then we still have the hole here. So there's nothing here. If you calculate the area of this circle, you've calculated more than you have because there's nothing here. So if they ever ask calculate the area of this circle, know that you have to minus this square part to get the actual one, unless they give it to us like they did in this question where they gave us everything, right? So they gave us the square hole has an area. This is not a length. This is not a diameter. This is the actual area. You don't need to calculate the area of the square. It's given to you. Make sure you read all of that. The circular coin has an area. So this circle has an area of 8.04 centimeters squared. It's already calculated for us. And the weight, they also gave us the weight in grams, which is 28.25 grams, right? Use the information above and answer the questions that follow. So this question says, define the term diameter regarding the diagram of the top surface of the coin, right? So my definition of the diameter is that it is a distance from the beginning of the circle across past the center of the circle to the end of the circle. But now this is not just any circle. This is a coin. So in this context, I would say the distance from the beginning of the coin through the center of the coin to the end of. Calculate the difference between the area and the circle coin and the square hole area in millimeters squared. What is the difference? Highest minus the lowest, but we know I'm looking for that minus part, so you know that the difference here will equal to, we have to minus the circular coin, which is 8.04 centimeters squared, minus. So to think of that, what is the difference? It's highest minus lowest, so you get that minus there, and then you say minus 0.9025 centimeters squared, 7.1375 centimeters squared. Now they said calculate the area in millimeters squared. So we have it here in centimeters squared. So we just have to convert it to millimeters squared. So what I would do is I would say 7.1375 and convert centimeter. How to convert centimeter to millimeter? You multiply by 10, but this is squared, so you multiply by 10 squared, right? See that? I'll repeat it. I have 7.1375 centimeters squared, which is the difference. They say, no, we don't want it in centimeters squared. We want it in millimeters squared. So I'm going to say, okay, I'm going to change centimeter to millimeter by multiplying by 10. But this is not centimeter. This is centimeter squared. So I'm going to say multiply by 10 squared. It will be 713.75 millimeters squared, right? The square hole area of the coin as a percentage of the circular coin area in the diagram shown above. The square hole, right? And as a percentage of the circular coin, that means it must be out of. Think of your marks. When you calculate your percentage of your marks, you say 102 divided by 150, then you multiply by 100, right? We're going to say what is the area of the whole percentage is equal to, we take the area of the whole and we put it at the top, because you always put at the top the one you're calculating the percentage for, centimeters squared, and then you divide that by what it must be saying it must be out of, which of the circular coin, right? So which is 804. So to multiply that by 100%, just to get the percentage, 10.2251248, right? And then just round off that to 11.23. Remember, I'm rounding off to 2 decimal, looking at the neighbor there, and then it's percentage. Express the weight of the coin. Express the weight of the coin in kilograms. Kilograms, so I'm not worried. From grams to kilograms, like I showed you here. Let me see. I showed you here. From grams, it's there, to kilograms. So from grams to kilograms, it's going to be 1, 2, 3. So I'm going to divide by 1,000. So I'm going to say 28.25 grams divided by 1,000. 0.02825 kilograms. And then 1.25, calculate the radius Calculate the radius of the coin in millimeters. So first of all, what is the radius? If you don't know what the radius is, then you won't be able to find it. So what is the radius? The radius is the distance from the center to the end. So it's half of the diameter. And luckily for us, they gave us the diameter, and it's 32 millimeters. So 32 millimeters, radius is equal to 32 millimeters divided by, take the diameter divided by 2, and you get 16 millimeters. Calculate the total weight of 15 coins in grams. One coin is 28.25 grams, and we have 15. They want us to calculate 15, and that would be 423.75 grams. Write down the exact time in hours and minutes if it was bought at 11:15 and sold 4 hours and 50 minutes later. So what time was it bought at 11:15? And then it was bought at 11:15. So they had it at 11:15, and then time started counting up until 4 hours and 50 minutes. It's increasing. The time is increasing. So we're going to say plus, right? So it's 11:55, 15. 11:15, it's 11:15, and then time starts counting while they have it, and then it counted for 4 hours and 50 minutes, right? And then we add that. So 5 plus 0 is 5, 1 plus 5 is 6, and 1 plus 4 is 5, and 1 plus 0 is 1. But we don't write 65 this side. I'm thinking you already know. We only end at 59 here. So I'm going to go here and say, what is 65 minus 60, which is this 1 hour here? And I have 0.5. Okay, so it's 0.5 here. And then I take this hour and bring it on this side. Then I have 1, 2. 1 plus 1 is 2, plus 4 is now 6, 1. So it's 16:05. Let me write it. At 16:05, it was sold.